Alright, so welcome to part 2. We're going to go over lesson 6 and as well as lesson 8, okay? Now, always follow the instructions. That's the one thing I've told you all. So make sure, you follow the instructions. Make this a little brighter, easier to see. Now, factorable, prime. Prime means that when we do the Xbox, we can't, go further above. That means in some parts, you don't have to completely solve the problem. You solve it by saying it's not prime. In order to do so, you have to show the work to show it's prime. So, we're just doing the Xbox here. Now, I already mentioned it. You don't have to do the box portion when the leading coefficient is 1. And if you notice all these right here, all the leading coefficients are 1, and it's true for all these problems right here, okay? So all you have to do is the X portion of it. So we have 1 times 5 is, 5, nice and easy. We got -6. Two numbers, that multiply to 5 and also give us -6. Well, that's going to end up being -5 and -1. The product of these two is 5 and the sum of these two is -6. Therefore, we are looking for the factors. So we're going to say our answers are n, because we got the variable n minus 1, and then we have n minus 5. And you're done. That's all the work requiring for these. We have x here, so we're going to do x, our x box. Leading coefficient of 1. 1 times 22, well, that's 22. -13. 1's negative. And then we have the positive on top, so it's going to be the same thing over here. They both have to be negative. So we have negative here. Now we know that they're going to add up, just like the 1 and 5, they're going to add up. So they have to add up to 13. We have 22. So the only ones we can actually use is 1 times 22, and then 2 times 11. 2 and 11 add up to 13, so that's -2, -11. So our answer is going to be x minus 2, x minus 11. See, there's a little bit more work here, just depending on the problem. If you're having trouble figuring out which numbers you want, remember, always work with the product, which ones multiply together, and then the sum of them, or difference in some cases, to find out which numbers you want. So we got 2 and 11, and there you go. We got 1 times 3, 2 here, positive, positive, so that means they have to add up, they have to both be positive. But the only ones to get 1, the only way to get 3 is actually 1 times 3. 3 and 1, which is the same thing. I could do negatives, but I don't want negatives because the bottom's not negative, okay? But if I add these together, I get 4. And since 4 is not the same as 2, we know this is going to be a case where it's prime, okay? Same thing for the bottom ones. All of them have a leading coefficient of 1. So do not worry about doing the box portion. That only happens when you have a leading coefficient that's 2 or higher. Anything that's not 1, basically, because you could have a negative. If we go to the back side of this page right here, factor expressions, completely factor expressions with higher powers. Look, it's the same thing as the page in the front, okay? If you notice these two, factoring 2 and 2, they're both divisible by 2. So we say 2b2 minus 1. And now it's the same thing as part number 1 from the other video, where I have the 2 in the front, there's nothing in the middle, and we have b minus 1, b plus 1. I could have used the Xbox method with this portion here, or remember, there's nothing in the middle, so we have a 0. 1 times -1 is -1. The only ones that can multiply to give us a -1 is 1, -1. And those are our answers right here. Because 1 minus 1 gives us a 0, which there's nothing in the middle portion, remember. Number 1 right here on lesson 7, if you notice, they all have an x. So we factor out or take out an x. We say x squared plus 3x and plus 2. And this problem might look familiar because this one right here, if I cover up the x right here, x2, 2, x2, 2x and 3. Very similar, right? But on this one, there's something special. If I actually use the Xbox method, 1 times 2 is 2. 3. The only ones that can give us 2 is 1 times 2, and 1 plus 2 is 3. So we can actually factor it out on this one. So we're going to have an x plus 1, x plus 2. And there you go. Very similar for the rest of them. Now, if you see these, they do have a leading coefficient of 1. These, A3, 9, A2, negative, and 14A, they all have an A. So make sure you factor out that A. And then you would do the Xbox method. I'll help you out with this one. It's A minus 7, A minus 2, and 4, and 3, and 2. The smallest exponent is 2, so we're going to take out n2 from everything. n2 minus 2n minus 3. And then you would do the Xbox method again. You would try it out, okay? Now, if you keep going to the bottom, if you notice this one right here on number 7, x2, y, and then you have a y here. So make sure you take out that y. 36x2, factor that one out. And now this problem becomes a difference of squares. So this is a perfect square, and a perfect square. Since there's no middle portion, you're going to have two different parentheses. So you're going to have y, the first parentheses, and then the second parentheses, and then you're going to fill it in. Remember, it's a difference of squares, so one of them's positive, one's negative, and then you just find out what's the square root of 36, square root of x squared, square root of 64. You know, just multiplying and dividing in this portion right here. That's lesson 7. Let's look at lesson number 8 really quick. Trinomials where a is not 1. Oh, okay. If a is not 1, then that's telling us we need to do the entire Xbox method. Since we know a is the leading coefficient is not 1, therefore we know that we're going to actually have to do the Xbox. 3 times 20 is going to give us negative 60, and a positive 7 we just bring down. Now, if I look at this, negative, positive, that means one of them has to be negative, one of them has to be positive, but the bigger one has to be positive because the difference after we subtract them is 7, and it's a positive. Now, I know that if I multiply 15 times 4, that gives us 60. That's one of them. I can also do 2 and 30. I can also do 6 and 10. I should have put a comma here. I'm trying to come up with another one. We have 6 and 10. We want a difference of 7, so we know we're kind of close here. We're way too far, so the numbers have to keep kind of getting closer and closer to each other. Let's come up with something else. We did the 30. We did 1 and 60 is not going to get us too far. If we do 230, that's not going to give us the same one. Remember, one of them has to be negative as well. If we do 20 and yes, we can also do 20 times 3. That gives us 17. It's going to give us 17. Excuse me, 17 if we subtract them together. So that's not the one I want. I gotta figure out what else I can use. I already used 2. I already used the 4. I haven't used 5, so I can actually try 5. Well, 5 times 12 gives me 60, and if I make the 5 a negative, well, 12 minus 5 is 7. So that's the numbers I want. Remember, the first box is this portion right here, the 3 and 2. Now, if you put an X instead of an N, you're still right. N just represents a number. It's a letter. Don't let it confuse you. The last portion right here, the negative 20. Bring it inside the box. We found our two values. Throw them in the box. Remember, for this portion right here, the order does not matter. You can have the negative 5n here or the 12n here. It doesn't matter. Block it off. Easier that way. They both have a negative, and they're both divisible by 5. Negative 5 times what gives us negative 5n? Well, that's just a regular n. n times what gives us 3n squared? Well, that's 3n. 3 times what gives us 12? That's easy, that's a 4. And look, 4 times negative 5 is negative 20. Therefore, our final answer is 3n and a negative 5 and then an n plus 4. There you go. So for these, lesson 8, you have to use the entire Xbox method, okay? Take your time. Let's do one more. And now, they are going to be bigger and bigger values, so that means you got to start, writing out the multiples for them, and it'll make it easier for you that way. So if we try this one right here, always use a calculator. You have a phone, dollar store has dollar calculators. Make sure you use them. They're useful tools. Let's look at number 4 really quick. One more to help you out. We have 3, 22, 16. Well, I just care about these two for the top portion. 3 times 16 is going to give us negative 48. Bring down to 22. And just by looking at it, I know it's a big difference compared to this number, so it has to be a small number and a really big one, which is going to be 24 times 2. Since this is negative, I want a negative 2. So I say negative 2, positive 24. X box. Bring down the values that are provided for us. And then we bring in the values that we found. Always easier to work with the smaller numbers to find the common factors. Negative 2. Well, negative 2 times what gives me 16? That's going to be 8. 8 times what gives me 24? That's 3. And I need that b. 3b times what gives us 3b squared? That's a regular b. And there you go. You have b plus 8. And then you have 3b minus 2. Now, the very bottom portion, problem number 10, factor. Look, make it easier for yourself. They all have A's. They all have B's. And 20, 20, and 5, they're all divisible by 5. So we're going to have a 5 in the front. We have A's, and we have at least 2 of them for each one. And the smallest amount we have for B's is just 1 each. Put that parentheses there. 5 times 4 gives us 20. A2 minus 4A. 5 divided by 5 is just 1. We got rid of all the A's, all the B's, so that's just plus 1. Once we get here, we want to do the Xbox method, ignoring this portion on the very front. So we're going to have 4 times 1 is 4. Negative 4. And if you look at these, what can we use? Well, that's easy. We're going to use negative 2 and negative 2. Because when we multiply these, it's going to turn into a positive 4. And if we add them, we get negative 4. So throw it in that X box now. We got plus 1. We got a 4A. Negative 2. Negative 2. A. Now, be careful. Look, we have a negative 2 and a positive 1. I can't pick 2 because 2 can't go into 1. So the biggest number we can only use is just 1. 1 times what gives us 1? That has to be 1. 1 times what gives us negative 2a? Well, by itself. It's multiplying number by 1, so it has to be itself. Negative 2a times what gives us positive 4a2? Well, that's going to be negative 2a. And look, negative times a positive is negative. So we bring down the first portion. We have 5a2b. And if you look, these two are exactly the same. So we can actually be like, we can just say negative 2a plus 1 squared. Because they're exactly the same, okay? That's what you're going to do for 11, 12, 13. I will get into this portion next. Make sure you complete all the way to lesson number 8. And I will make a part 3 of the video to help you understand the next pages.